Hello everyone, welcome back to Math 110. Today's lesson is lesson 1.5. We're going to do some prep skills to get us started out. Skill 1 is reading information from a table. And our book is telling us that the key to finding information accurately from a table is to carefully read the row and column headings so that you know exactly what information is being provided. So this thing is basically called a contingency table, so that we've got some age group here. Here's males something, females, column information, total column information. This age group is basically telling us that they've broken this thing down into age groups. Here's the 12 to 19 age group. So the males aged 12 to 19, their smoking rate in Canada is 8.3%. Age group 12 to 19 for females is only 7.1%, which gives you a total of the population of 7.7%. So if you wanted to know the smoking rate in Canada for age group of 35 to 44, you would go down, find your group that you're looking for, and then going over, and let's say if we wanted to know for females, it would be 15.5%. With this type of table, you can kind of go through and pick out key information. What is the highest smoking rate for what age group? Well, the 29.6 for males occurs in the 20 to 34 age group. For females, it is as well as 20 to 34. In every age group, men are more likely to smoke than women. We can see that. The lowest rate among females is 12 to 19. That's the 7.1%. So they also want us to be able to set time scales based on the information that we're provided. When data are provided over some time period, like the smoking rate in the United States, for selected years from 1965 to 2013, we typically don't use the year, day, clock, time. Frequently, it is done, instead of the date, it'll be based on a base year, some base year, and we'll call that 0. So here, if we call 1965 time the base year of 0, then the 70 would be 5 years past our base year. The 1980 would be 15 years past the base year, and so forth. So we've done this through the 5. And here's 10 more, 10 more, 10 more through. So then we can just look and see the percentage of smokers based on those years from. So for a number line, we're going to do graphs in a little while. And if we want to do graphs, number scales, entering information on number scales, we want to do it with according to a scale that is appropriate. So I could start right here with a number line, and I could say, well, let's call this one 0. And I could have this -1, -2, 1, 2, 3. But if I wanted to have something between 0 and 20, if I need to have the information up there and plot some points, put some representative information, I would need a bigger scale. So here they've done a scale of 5, and each tick mark would be 5. Say 5, 10, 15, 20, 25 to label it. Here's only the positive, but if I need negative numbers, I could shift over everything. And now I want this bigger scale here, because I need to go from -50 to 50. So I'm going to use, here is a 25, so -50 down to -25, down to 0, plus 25, plus 50, 75. So each one of these tick marks would be representing of a different 25. So here is, for the table summarizing smoking rates in camera, what group had the lowest overall rate, who was more likely to smoke. Those we would go through and look at those. The first table describes temperature on a certain day, so we're going to look at a little different one now, between noon and 8 p.m. In the second table, fill in the time scale with a noon corresponding to time 0. So also fill in the descriptive header at the beginning of the top row. So we would put something like base time noon. And so if our noon is, this would be our 0, that would be 1, 2, 3, 4, 5, 6, 7. They've also given us a couple of numbers down here in number 3, and just says label an appropriate scale. I would basically say, well, what have I got to work with? Here I've got like 1, 2, 3, 4, 5, 6 tick marks, but 5 actually spaces in between those. So I would need to get everything between 15, the largest, and -9. So I'd have 15 forward and 9 back. So I'd have to have almost 25. I went with 25, 1, 2, 3, 4, 5. If I had 5 for each one of these, 5 into the 25, I would start here at 0. Let's go to 0 here. -5, -10, that would give me the -9. So I'd want my 0 here. -5, 10, 15, that would give me everything there. So I would want it in whole numbers. So if I divide it out and I got a decimal, I certainly wouldn't want a decimal number for these. Here I need to go from -3,000 up to 2,500. So that's 3,000 plus 2,500, 5,500. If I wanted those into the very same 5 spots, I would get 5,500 divided by 5. That's 1,100 per spot. I may want to do these as 2,000 and then just kind of label it in the middle where that endpoint is. So let's look at some things from class. Most people know that the economy in the United States went through a very rough patch starting in late 2007. How much we've recovered depends on who you asked, as there are conflicting numbers and viewpoints. One common way to measure the strength of the economy is through unemployment numbers. So these tables below display the average annual unemployment rate for the years 1992 to 2015, and this has continued. Here's the top up through 03, picks it back up at 04 and runs it through 2015. This kind of where we have dates as years and then some other type of data, reference data, this is called a time series, and this is the time series data. So a time series graph actually plots these things. What we would like to do is take the years, and that would be the x-axis, okay, that's usually the time, and then whatever variable we're trying to represent as the y-axis. So if I look just from the table, it says use the table to write a verbal description of trends in the unemployment rate over that 24-year period. Put myself right up here. The rate dropped steadily from 1992 to 2000. So here we're just going to kind of go through and say, yep, it looks like it dropped from 1992 down to the year 2000, and then it started to increase, and then started decreasing again, and then a big jump here, and then went up, and then started going back down. So those little things are called trends, where over several years it's continuing to do the same thing. If we graph it, this is a better picture of it so that you can actually see those trends over the years. So here was that decreasing trend to 2000, then up, then back down, up, and then back down. So it would be the same thing, the same description, but just a different way of interpreting and looking at it as a summary. This is a much better way to summarize. Okay. What we've basically done when we've generated this is done this as a graph. I've done this as here's an axis. This is called the x-axis. The y-axis is the vertical scale. And we've just basically plotted these things using those scales for the graphs that we wanted to do. We wanted to represent 92 to 2016, and then going from 0 to 12% to give you a nice scale that we could work with between here. So these are not the same scale as this. This is percentages, and these are years, and the tick marks are, you just kind of have to go through and pick them out. Each particular point can be referenced as a coordinate. Okay. In graphs, and when we're looking at a graph of an XY coordinate system, we read the X point off first. So this would be 2016. I would write it as 2016, and then the 4.9%. So let's look a little more at this. Here is basically what we're doing, but we're starting out with just here's a number line, negative numbers to positive numbers, and I'm calling that the X number line. Here's the Y, and this thing together, when we write these things, perpendicular axis, this is Y-axis, the X-axis, this is a rectangular coordinate system. And here we can represent pairs of points, just like we did that quick, here's the year, here's the percentage rate, and use that in here as well. So when we're in math, when we need to plot points on this so that we can visually see them, we just go, we find the point corresponding to the X value along the X-axis, and then go along the Y and find the corresponding Y value. We draw a point, and then many times we'll want to label it with those XY coordinates. So here it is, the coordinates of the origin, that's basically 0, 0, X, Y. What distance does each box on the grid represent along the X-axis? Well, we've got a 5 here. I'm going to assume at 1, 1, 2, 3, 4, 5. There you go. So that was just 1. If I do the same thing, if I start out with 1, 1, 2, 3, 4, 5, I don't match the 10. So obviously this has to be something bigger, maybe 2. 2, 4, 6, 8, 10. Okay. So they're asking us to plot each of these following points on the rectangular coordinate system above. Here they are, but I'm going to go in and I'm going to do a quick sketch. I'm going to use Notepad to set these things up. So I'm going to escape out of here. I'm going to put this over. I'm going to put this over. And I want to do 4, 0. Let's go up here. I'm going to open this up. And I'm going to draw a little coordinate axis up here. Hopefully I can get these things in. Get some shapes going. So if I do this, so I have an axis, and then I'm going to use the very same thing. I've got it pretty close along those coordinates. So each one of these would be 1, 2, 3, 4, 5. So here would be my 5. Let me click on this. 1, 2, 3, 4, 5. And then 2, 4, 6, 8, 10. That would be my 10. And then I want to plot 4, 0. So I'm going to go up here. I'm going to plot 4, 0. So the first one I'm going to go to is along my 4. 1, 2, 3, 4. So here's my 4. And then I'm going to go up 0. So that's that basic point right there. And I could write this as a coordinate 4, 0. 0, negative 8. This is to scale, remember, so I'm going to go, here's my x 0 is along this. So negative 2, negative 4, negative 6, negative 8. I go right here, I draw my little point across here, 0, negative 8. Negative 3, negative 4, negative 1, negative 2, negative 3, and then negative 4, negative 2, so each one of those were 2. So that point right there, I would label as negative 3, negative 4. And finally 2, 7, 1, 2, but I got to go up by 2s, 2, 4, 6, 8, somewhere right in here is going to be the point 2, 7. Okay, hope that's helpful. We would also want some other information here. We could finish filling this thing out. This is my x-axis. There's my y-axis. Each one of those, again, we put tick marks if we wanted to fill this in, but that'll give us that. Okay. So there's our scale. Let's continue along here from current slide, and basically that finishes it out. So I'll see you next time. I hope you found this informative. Have a good day.